Here we try again, and I'll explain what happened in a minute, but I'm just waiting for my scripts to start up. Should be automatically creating my chat window, and just need to bring that up, and I think we're there. Hi, Juanja. I'm doing a terrible job of pronouncing your name. Good to see you. I remember you from a while ago. Yeah, so I've got a fancy lapel microphone. It's one of those, wireless mics, and the receiver, the battery had run out. And then I was, so I plugged it into the charger, and then there was this horrible noise because the chargers are very electrically noisy. So it's on a battery right now. It's being charged by a battery. So now the audio quality is all right. So it works very well. Although I'm just getting to know it. So I mean, that's a bit disappointing that it's very noisy if you try to use it plugged into an adapter. Oh yes, it was a podcast. Okay. Yeah, well, good to see you. How are you doing? What adventures have you been on? Feel free to fill us all in. So yeah, this is only my second broadcast after a very long break, but I'm intending to do more, and I've got quite a lot of projects going on. This is what I'm going to do right now is working on my ACORN atom recreation of the game Letteroids, which I did in 1980 or so. It's my first fully assembly video game. And I got an ACORN atom off eBay. Actually, I've got two now. And recently I've been working on that. I had to restore the new one that I got, which will fix that one up. And the thing is that about a year ago we moved into this new place. This new place has space. It's amazing how long it takes to settle down. So you can see a bit of my sort of studio here, which is a mess. I need to do a tidy up. And downstairs I've got a workshop where the ACORN atom is. And I started doing assembly programming again, which is a lot of fun, and that's what I'm doing here. And if all being well, I should be able to print F5 in something changed. F5 here in Emacs, and like magic, you see, that's my. Nothing really changes. After 40 years, you still have this point of you want to have a development environment where you can press one button and it just compiles and runs the game. So that's what's happening here. I'm using a assembler called, what's it called again? It's Acme, the Acme assembler. And so when I hit F5, it compiles my my code, my game code, creates this test A, puts it through a tool I wrote that converts it into a file that looks like a cassette file, which is then loaded by the emulator, which is Atomulator, and then resets the atom, and then feeds in the key presses that you see there, so that I don't have to type that every time. And so this helps quite a lot. You can see the code in this window here. This is the actual compiled code. You see how big the code is. I'm already getting up to 2K, and all I forgot are 2 sprites, but yeah, that's interesting. And the sprites, I'm trying to draw these sprites as efficiently as possible, and so it's already pretty hardcore assembly programming. Just to know about that machine, already gets Mr. FPGA, and I have no... Oh, right. So you're thinking, you do you... Yeah, it is back to the roots, and it's very important, I found. I didn't realise how important it would be until I'm looking at this camera. That camera's not even on. You're over here, yes. I didn't know how important it would be until I did it. You see, I've been programming since I was a teenager, and I've never stopped. I've always been programming. And I've gone through the whole of the history of software engineering from back in those days. It was 6502, 8-bit assembler, or assembly. And then sort of migrated along with the hardware and also the software, and things like C++ and object-oriented programming, and you know, different game consoles and so on. It's like now 40 years later, there are some parts of me that lost some of the joy of programming because of engineering. I think probably the most horrible instance of that was working on Kickoff Revival, where I spent 80% of my time just wrangling Unity, and that's not actually software engineering or game design, really. It's something else entirely. And going back to doing some retro work, it's reminded me of the passion I had as all those years ago, and it's fun. And this is the funny thing, is you would think that going back to programming in assembly would be tedious, it would be difficult. It is, but in a different way. The thing is that it isn't, is wrangling. And by that I mean, yeah, you can get stuck. When you're stuck, it's your own fault. So you've made a mistake in your code. That's the way it always was. And that was the thing that made it compelling. It was you were the master of your own destiny. If there was a mistake, it was your mistake. You owned it 100%. So yes, I can remember I might spend an entire day or 2 days not being able to get something to work. I would go and sleep on it and come back the next day. And it was amazing how it wouldn't take that long the next day, usually, right? But you owned it. Now what do you have? It doesn't work because something's gone wrong with this API call. Is it a bug with the compiler? Is it a bug with the API? What is it? And going back to writing an assembly where you own everything, and that feels really good. And it's reminding me of the joy of software engineering. It's also highlighting that we may have made some mistakes in our progress, and we can see this in the fact that software is getting slower and slower. I don't know if you've noticed. I mean, basically you've got Moore's law, which has been this kind of exponential curve thing, and it's sort of double the power every 18 months or whatever it is. And what that has done is hidden the fact that our software engineering skills have been on a decline. Well, Moore's law has come to an end, but the decline is continuing because that decline has an inertia, has a momentum. And so we're actually getting to the point where software is becoming, in many, not everywhere, but in a number of areas, is becoming kind of worse and worse. I mean, just look at your mobile phone and see how quickly it responds to input. Sometimes it's shocking. But anyway, I digress. Let me check the chat and then I'll actually start some programming. I saw some shorts about loading games from a tape. Yes, so that there I had a tape. It's this tape. Actually, I think I've got it over here. Yeah, this tape. No, it wasn't this tape. It was a different one. But anyway, these things. And I had the tape, and the quality of the audio on it was not good. And so I set myself a challenge to recover the game. It was actually a backgammon game. So I set the challenge to recover that. And so I wrote custom tools in C++ to read in that audio and then analyze the frequency shift key and reconstruct that and then export it as another audio. And the problem there is that it needed some, to detect the signals properly between two frequencies, but also the facility for debugging was very important. I had to draw the waveform out and see what it thought it was, and I could look at it by eye and see where it agreed or disagreed. It took ages actually, but in the end I got there. So now I have the means to recover these tapes. But that's sort of, yeah. Every optimization, every byte counts. It ends up that way. But anyway, what we have here, you can see two. Oh, no, wait a minute. You're talking about FPGAs. If you are you an FPGA developer? Do you know about FPGAs? If you do, let's talk, because I have some very sneaky ideas, but I don't know anything about FPGAs. So maybe we should talk about that. Anyway, so to get back to the game, so I'm recreating Letteroids. Letteroids is a game that was obviously some connection with asteroids and some connection with letters. And now you can see I have letters. So that's why you see letter A's here. Need letters A to J eventually. And I'd be developing the sprite engine for this. And this is how far I've got. 2 sprites. The previous stream I was debugging why 2 sprites wasn't working. And you can see the moment when I realized the error, which was the routine for calculating the address, if I remember rightly. I think it was this one. And what I had done, oh, it's still there? No, that's correct. It's the out that was the, yes, right. I was missing that comma X. And this meant that the first sprite would work, but I couldn't get 2 sprites to work at the same time. So, and that's because it was missing the index on this for nightmare. But anyway, I fixed it. So now I've got 2 sprites. And obviously I want to go further and see how many sprites I can draw. This is not as easy as you might think. I used to play games as well. Well, let's talk, because I think you know something about FPGAs. I know very, very little. So what we have is, I'm going to demonstrate something so that for context as to why this might be trickier than you think, because you just see a couple of A's moving around the screen, but they're moving smoothly and per pixel. And it's the per pixel thing that makes it complicated. But also the following, if I find the right place in here, where was I? So in the main loop, this is the main loop. I'm just going to comment out the VSyncs. Well, we all know about VSyncs, don't we? Everybody talks about V-Syncs, and should you do your first-person shooter with V-Sync on or V-Sync off and tearing on the screen. And so here is a video game from 40 years ago that I'm recreating. I'm going through the same steps I'd have gone through 40 years ago. And look, there's a V-Sync. V-Sync is a very old thing. It's been there since forever. And now I'm going to turn off V-Sync. So we'd expect this to go really fast. And then, oh, tragedy, this emulator is so good, it will show you this. And let me run with that off. And you can see it's certainly going very fast, aren't they? Whee! But what's all this noise on the screen? And this is the tragedy. No, I don't call it a tragedy. This was the challenge of the ACORN Atom, a serious challenge, because the way the ACORN Atom hardware works, there is VRAM, yes, VRAM from 40 years ago. So your things don't really change that much. There was VRAM, 6K of VRAM. I mean, you might moan if you only have 6 gigabytes of VRAM these days. That's 1,000,000 times the amount of VRAM of the ACORN Atom. Supported up to 6K. And it cost a lot, that 6K back then. So 6K of VRAM, and then you could expand normal memory, CPU memory if you like, you could expand that up to 6K as well. And although you could think of it as VRAM and CPU memory or whatever, it's actually all on the CPU, really. So you could use the video RAM also for programs or anything else that you wanted. Sort of. Because well, maybe you can if you use the lower resolution. Because maybe, I don't know, if you might get snow anyway, because this snow problem is the fact that you have the VRAM and you have the video circuitry and you have the CPU, and they're both accessing the same memory. And then you can imagine what happens if the video circuitry is trying to access the memory at the same time that it's being drawn. And you end up with snow. So what this meant was you had a very short window in which to draw to the screen so that you didn't have snow. And this limitation was wonderful because it was great training. I mean, it wasn't wonderful at the time, but it was great training. I'll just put the VRAM back in. You can see that's no snow, no noise, but because it's very carefully synchronized to the VSync. First of all, the VSync instruction, call a routine that's in the ROM of the operating system of the ACORN, and that waits until the beam reaches the bottom of the beam. The scan of the display, it scans left to right, top down, and then when it gets to the end here, this thing would fire off, and you're waiting for that. And so the VSync instruction waits until the beam gets to here, and then at this point there is a relatively short period of time where more lines are sort of scanned that aren't drawn, and then it returns back up to the top, and there's presumably also some up here, and then eventually it starts accessing the RAM again. So if you want to draw without that noise, you have to do all of your drawing in this tiny window that you have here. Okay, now back to the sprite. That A is moving across the screen very smoothly. The thing to remember is that the display is mapped with 8 pixels per byte. Now that is very different from modern video cards. Modern video cards will have 32 bits often. I mean, really only need 24 if you have red, green and blue and 8 bits for each one. That 24 bits is a little bit awkward in terms of bus size, so maybe there could be 32 bits. So just for the sake of argument, I'm going to say 32 bits, and maybe it doesn't use 8 of them, or it has more than 1 million, 20 million, or whatever it is, colours, million colours. It's a million colours. 24, oh no, 4 million colours. Anyway, whatever, I digress. So the point there is that you would basically have 1 pixel is 4 bytes. And so you don't have any problems with having to mess around with bits, but that's not the case on these old hardware. In this old hardware, that would be very expensive. I mean, you're looking at a screen that's got 6K of RAM on it. It's 32 times 8 pixels across, and I think 24, I think, down by 8, 24 times 8 down. And if we used 1 byte per pixel, we might be able to have, nice different sort of shades of grey in there, I guess, but you would be needing 8 times the amount of memory. Now on an ACORN System 1, sorry, on an ACORN Atom, well, you've got your 6K, let's multiply it by 8, 6 8s are 48. That's 48K of RAM. This is a problem because the entire address space of the ACORN Atom is 64K. This is quite expensive. The BBC Micro had 20K because it used, if I remember rightly, it probably used a lookup table, color palette. But anyway, the point there is, if you want to do this kind of smooth movement, you literally have to take your sprite image, like if this is, sorry, this sprite image here, and you want to move it over a pixel, you have to rotate it. You have to shift it, and you have to shift it up to 8 times, or 7, I guess, 7 times. And that's what's happening. This A here is not, but this one, it's every time I need to draw it, I have to rotate or shift the bits. Now you'll notice that you might, well, you won't notice, but here's the thing. That shift is expensive. The code for doing that shift is an unrolled loop, and it's here. And I've got them as macros so that they sort of stay as like in line, right? Shift sprite right, shift sprite left. And then because of the fact that you are shifting it over, that sprite is now straddling 2 bytes. So whereas you could just write into video memory 8 bytes, in theory, to do your 8 pixel wide sprite, now you have to do 16 bits or 2 bytes. So the whole sprite, which is 8 lines high, actually requires 16 bytes. So those 2 sprites are actually being drawn as 32 bytes in total, 16 in each one, because when you shift over, you have to shift over into the second byte. And that's why you have here 16 instructions, the arithmetic shift left of the first one, which shifts the bits, and the end bit goes into the carry flag, and then the second one is a roll that shifts out of the carry flag into the byte, and you can use that to chain together shifts, because this is a 16-bit shift that I have to do. I have to do 16-bit shift on an 8-bit machine. So you could do it like that. All indexed by X. This is expensive. So this is what I've done. Because I reckon this is important, for performance. Is instead of shifting these at the moment that they're drawn, they're shifted, it's actually shifting the sprite in memory, the source sprite. It's literally like take your sprite that you are copying to the screen and shift that sprite left and right the amount that's needed, and then copy it to the screen. So next time it remembers where it is, it doesn't have to shift it again unless it needs to move. And then you think, well, wait, what do you get from that? Well, what you get from it is that, see, this is 1 bit that's shifted here. If you want to shift 7 bits, you have to do this 7 times. That's pretty expensive. But normally your sprites are just moving like this and only need to shift once. So I believe this will save a lot of time overall. It's caching, in effect, it's caching the rotation. Let me check that on the chat. $6K. Yeah, the sprite is moving smooth because it's in lockstep with the VSync. It's perfectly synchronized with the VSync. And also I'm moving 1 pixel per VSync, because that's the other thing that you get with this, is that you're always moving things around on the screen on the pixel grid. You can get a similar kind of smoothness in modern contexts only if certain conditions are met. And these conditions, there's a lot of them, and so you don't get this kind of smoothness generally in modern games. You just won't. And it's smoother in real life. This might look kind of smooth on the video here, but you've got the whole video chopping this up and causing confusion. But when you actually run it on the hardware, the original hardware, it is perfectly smooth. There's no jitter at all. There's no stutter at all. And it's the kind of thing that I miss in modern games. So what are the conditions which are required for perfectly smooth movement? The first is you need a totally reliable VSync that doesn't stutter or change or move, so that you do the next step in the animation always on a VSync reliably. Okay, now on computers that's pretty difficult because the operating system keeps popping up and saying, I don't care that you're playing a video game, I've got something really important to do, like for example send that data that will tell an advertiser what you're interested in now, or whatever it is that it's doing. So the operating system interferes. This is the advantage of game consoles, they're much more controlled in this respect, and it's much more possible to have a completely smooth lock to VSync. That's the first requirement. But the next requirement is very interesting, because you must move the same amount every frame if you want to have completely smooth movement. The same amount every frame in pixels. Now, if you have enough pixels, maybe it doesn't matter quite so much, but you'd be surprised. So perfectly smooth movement arrives is when you're moving a constant amount, 1 pixel or 2 pixels or whatever, every frame, and nothing less than 1 pixel. If you move half a pixel per frame, you get a very interesting, so it's like 1 pixel every 2 frames, you will get a double imaging issue. This is a similar issue. So I'm going into all this stuff so you never wanted to know about sprites. This problem that you get in the cinema with panning. It's like they pan a scene, maybe it's a city scene, and as you pan across it, the buildings are all going. You don't see any sharp edges. there's a kind of two images. You even see this in video games in animation, the difference between a character which is running at 60 FPS or 30 FPS. The 30 FPS one is somehow not as sharp. The thing is, I've done a lot of studying of the reasoning behind this, and stuff that I read on it about it is actually, a lot of it is nonsense and wrong. I'm sorry. I'm going to tell you exactly why. It's not the frame rate. I learned this about 20 years ago when I got one of those fancy double rate monitors, 120 FPS, and I was using the Xbox on it. And I thought, great, at this frame rate, you know, if the video game drops down to 60 FPS, it doesn't matter. It's going to be fast and you're going to have smooth movement. And no, you don't. If you have a monitor, this is totally true. You're going to perhaps think I'm talking rubbish here, but I'm really not. If you have a monitor where the image is being updated 120 times a second, but that's the screen is updating 120 times a second, but you animate something on it at 60 frames per second, you're back to square one. You will see two images. You will see the stuttering. You see, the stuttering isn't caused by the frame rate. The stuttering is caused by the fact that it's drawn twice. And you go back to projectors in cinemas, you would think, here's an image, here's the next image, here's the next image, and that's what they would do. But that isn't what they do. It's like, here's the image, and here's the image again, and here's the image again. And because it's flickering, it flashes faster, in part because then if you flash faster, right, then you will not be annoyed by the low flickering rate. And that seems great, but there is a problem. It means that this happens, boom, 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 boom. And you think, what does that matter? It took me years to figure it out. It's a problem because if you imagine an object moving, I'm doing more talking here, I miss doing this. Right, look, here you've got an object moving across the screen, right? So if it's displayed twice, so it's like display here and display it again, display it here, display it again, display it here, display it again, because the monitor is going at 60 FPS, but my game is only going at 30. This is what happens. Your eye, over here, your eye sees that, and sees it again, and it's moved. Well, this movement means that your eye is tracking, just like if you're looking at those letters there, your eye is tracking the letters. Your eye is tracking the movement of this thing. There, it tracks it. In fact, I guarantee that if I do this across the screen, you're going to start noticing that it's juddering. But there's a whole bunch of reasons that you can have that juddering. I keep forgetting that camera's over there. What I'm talking about is you see it here, but your eye has moved. Why? Because it's going to follow the movement. Your eye moves smoothly as to track the movement of the object. Think about that. Your eye is moving smoothly, but while your eye is moving smoothly, it goes, here's an image on your retina. Here's an image on your retina. Do you see the point? Two images, but your eye moved. So where your eye has shifted over a bit, you get the second image that is not shifted over because it's displayed twice. And as a result, what you get are two images of that. and you no longer have a sharp representation of the object. You actually have two images of the object on your retina, and the two images are flickering in effect. And that is the reason why you get that juddering. You're trying to track the movement of the edge of a building, right? You're trying to track the movement at the edge of the building, but because it gets displayed twice or three times or four times, whatever it is, you actually get multiple images stamped onto your retina because your eye is in the process of moving. And I remember when I finally figured this out, I was like, oh gosh, I've been thinking about this for years. And it's so easy to miss that. It's like, if you've ever seen LED signs, I don't know if you've ever seen this, those LED signs that scroll. And you're looking at it and it goes, while it's scrolling, the characters seem to lean. Why do they lean? Well, that's because they're being drawn from top to bottom. And as you are looking, you are tracking the movement with your eye. Your eye is moving, and what you're actually seeing is a representation of your eye moving. And that creates the illusion that there's a lead. So if you want to have completely smooth movement of a sprite, you need to have a total lock on your V-Sync, total consistency in the timing of the V-Sync, and total consistency of movement of the sprite or whatever. And you can only really get that if you're moving integer amounts of pixels per frame. And that hardly ever happens in the modern day, because nobody's concerned with pixels. What you have is some other grid that you do your, or even floating point, you know, obviously not grid, just numbers for the positions of things. And then it's drawn to the nearest matching position on the screen. And you will then lose the clarity. And so if you really want the best clarity, you go back to the original hardware. And the design of games like the one I'm making now, where the game is designed around that pixel grid. So I don't know if that made any sense. Every shift coded manual one by one. The shifts, yeah, the shifts have to be done. They're shifting all the time. And in fact, in this case, it's going to have to do one shift for the one that's moving diagonally. And then the second one is it has to shift back for that one. But as I was saying, you have to do the drawing in a very short window from the beam being at the bottom of the screen to coming back at the top. So this is what I did. Because, you know, I'm just drawing two A's on here, but no, it's quite complicated. I've got a function here, shift sprite 2, which shifts the source sprite left or right a certain number of pixels, as I was just saying. I have a routine to draw to the screen, and so that takes it does a blit in the, that word didn't exist, I don't think, in 1980, but I remember it being used for the Amiga. There was a hardware on the Amiga for doing this called the blitter. Well, this is my blitter. It's a software blitter, and it's a big chain, as you can see here. And what it's doing is taking the data from the sprite buffer that has been shifted, by drawing buffer, I'll come to that in a minute, and it's XORing it with the screen. So I have on this macro, I give it from and to, where from is the address in memory where the image that I want to put onto the screen is, and the to is the address on the screen. At this point, the data has been rotated already. Okay, and this, you can see in here, I'm loading, that's load to the accumulator, the to address, as the, you know, and there's a y, because the y has to do, well, which is set to 0 here. I increment y or add to y to sort of do the blit. So it does it, add one to it to do the byte next to the, because I'm doing 16 bits at a time, so I have to do 2 bytes. So that's y and y plus 1, and then y plus 31, which makes a total of 32, which takes us to the next line underneath. And it's reading the screen memory, doing an exclusive OR with the data from the draw buffer, and then stores it back, and does that 16 times. And it's unrolled to try and keep it as fast as possible. So what's going on here in my main loop? Update is the actual sort of game code. So that's the code that is actually moving my sprites around. And then I have move sprite and draw sprite, but I have 2 of them because I've got a kind of double buffer going on for reasons that will hopefully become clear in a minute. So when I start, I clear the screen, I move sprites. What move sprite actually does is it does more than moving the sprite. It actually, well, let's take a look. It executes move sprite. It does it for all the sprites. So the move sprite 1 is the routine that actually moves in inverted comma the sprite. This calculates the address that the sprite needs to be drawn into screen memory from its XY coordinates. Calculates, that's a macro that I did there, which we can see here. And this is doing some math, which is funny, because this is a 6502 and you don't have even a multiply. So, yeah, we'll come back to that maybe, but it's, well, it takes the X coordinate and it stores it in an address, sorry, Y coordinate, I beg your pardon, YH, the high byte of the Y coordinate. It takes that and it then proceeds to multiply it by 32. So this is a, this is 5-bit shift. 5-bit 16, no, 5-step 16-bit shift, which is why these are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Actually, that doesn't quite work out, does it? It's 6 bits. Yeah, sorry, not 5, 6. 5 bits would be 16. So I have to do those shifts. So it multiplies that by 32. So that gives me the beginning of the line. And then I add to it the X coordinate divided by 8. That's the logical shift right. Shift it right 3 bits. Anyway, it calculates that and it stores it in an address for usage. So that's fine. And then it does the shift sprite 2. So this is when it actually shifts the source data, if you will. The actual sprite data gets shifted to wherever it needs to be for when it gets drawn. So I have is like stages. It's like just like a modern graphics pipeline, but old-fashioned, but it's still got the kinds of elements that are there. It's almost, well, you'll see. So if I go to move sprites, that move sprites, then what it's done is it's actually calculated the address that the sprites need to be, and it stores them in memory for each sprite. So I've calculated ahead of time the address and the amount of rotation that is needed for each of the sprites. And I've just looked at it and I think I've got a bug. It's great to talk over the code. Let me just check something. Because move sprite. No, it's fine. It's good. And then we have the draw sprites. So what draw sprites does is it calls the draw sprite function for each sprite, and this is the one that takes the prepared image of the sprite that I want to have on the screen, and it does the buffer XOR with screen, the function I showed you already. So in other words, every sprite has a 16-bit buffer of the pre-rotated image ready, which can be prepared while the beam is drawing everything, so that when it hits the VSync, all it needs to do is blit the rotated sprite onto the screen. So all of this dance is done just so that I can do as much of the calculation as possible before the VSync, so that the very precious VSync period for updating the screen has as little going on as possible. And so this was the kind of optimization that you would have to do back then. It's probably no different from writing a highly optimized, graphics driver, but maybe not as complicated. But who knows? It seems pretty complicated. So if we get back to the main loop, so draw sprites. So first of all, I start by drawing the sprites that in their initial position. Move sprites is actually setting it up so that there is an image available for all the sprites on the screen ready for blitting, and draw sprites actually does the blitting. So then I go into the main loop, I do an update that moves the sprites locations. I then do a move sprites to, why to? Because I need to be able to clear the sprite. It's no good. I'm not going to have success in what I'm trying to do, right, if I don't clear the sprite. You'll notice the sprite's clear. This means that they have to be removed and then plotted. And that removing and replotting of the sprite has to happen in this same little period between the end and the start at the VSync. So what I do is I remember, in effect, where I drew it before, and then I draw it again, because I'm using exclusive OR plotting. And this is exactly the technique I used in Kickoff. And so the technique, which this is my favorite way of dealing with sprites. It does mean that if they draw the two sprites on top of each other, they cancel each other out. That's the disadvantage, but I just live with that. It's not that bad. But what you get for the advantage is simplicity in your sprite routine, and beautifully, you can draw stuff on the screen and it doesn't get wiped out by sprites. If you imagine that I drew a horizontal line across here, then this character, when you plot it on top of your line, is going to invert all the bits of the line. So any part of the line where you draw also the letter, if it was bright, it becomes dark. Okay, so they cancel each other out. This seems bad, but it has this wonderful property that if you draw the sprite again, it just restores everything back to where it was. And no matter how many times you plot and how many things you plot on top of each other, they will never leave any residue or mark on the screen. It's so beautiful in that respect that I just always loved that way of doing it. And that's the way that I'm doing this here, though you can't see it. We'll see it later when I develop the project further. So this exclusive OR plotting means that during the period from here to here, that's during the V blank period, I need to clear what I had drawn before and plot at the same time plot the new position, and that's why I have a front and back buffer, in a sense, buffer 1 and buffer 2. So here I prepare everything in buffer 1, and now I do an update, so that this is like the game update, physics update, whatever. And then I draw the new positions of everything. I prepare, right, the new positions for everything in the second buffer. Then I do a VSync, and then I do the draw sprites all, which is basically a draw sprites 1 and a draw sprites 2 combined together. And so this draws everything. It redraws everything it drawn before from the previous buffer, buffer 1, thus clearing them, and then draws everything in buffer 2, thus drawing the new position. And so in this way, everything has magically moved in the VSync in the most efficient way possible so that we can cram in as many sprites as we can. I remember only being able to do 3 sprites in this original game, but this was 40 years ago, and I wasn't as good an engineer as as experienced engineer as I am now. I think this is going to be more than I was able to do back then. I think I might be able to get 6 sprites at 60 FPS, and if I do manage to get 6 sprites at 60 FPS on a 1 megahertz 8-bit processor, this will make you think, because 1 megahertz, today's machines are at 4 gigahertz. So the difference between 1 megahertz and 4 gigahertz is 4,000. And they're also 64-bit machines. So we could go get the calculator out, and we'll go, right, so today's processors are 4,000 times faster, but they work on 8 times the bit. So you could say they're 32 times, 1,000 times faster, and we haven't even started looking at the GPU yet. So without using a GPU, if we were to scale this kind of programming technique to modern hardware, a 4 gigahertz single core processor, 1 core. Shall I multiply it up? Okay, I'll do it some more then. We could say that we could go, let's say 16 cores. Okay, 512,000. And then I multiply it by my 6, because if I'm able to get 6, it would be the equivalent of, on modern hardware, running 3 million sprites at 60 FPS. 3 million sprites. Have a think about that a minute. Anyway, so to get back to the code here, you can see how this works. I've drawn in buffer 1, I prepare in buffer 2, I have a VSync, I draw everything, this causes the thing to shift, I do another physics update, I then draw to buffer 1, so the other buffer, so I'm in effect flipping the buffers over, do a VSync, draw all, jump back to the beginning. And there's a tour of what's going on in this code. And so with that, I think I'll start doing some actual programming after I check the Blitter. That's the Amiga, and the Atari didn't. Yeah, yes, I used exactly that technique on both the Amiga and the ST. What I had to do on the ST was not have a nice, pretty graphic background, and the Amiga allowed you to have tiles. There was no tiling on the Atari ST. There was no even sort of, you couldn't have any hardware scrolling. You couldn't shift the image around by hardware. So I made use of the Amiga stuff, but it wasn't really possible to stick to 60 FPS on the, or 50 FPS on the ST, unless you kept the graphics really simple. So I chose to keep the graphics simple. So yeah. Anyway, right. Let's see what I can do here, because it'd be nice to get more. We've got 2 sprites. I'm going to see if I can get to 3. Now, there are so many tricks here. This is the data for the different sprites. This is, you can't get more data orientated than this. So when we talk about data orientated design as being something fancy and new, this was the way it always was until things changed. I don't have structures here. I have arrays in effect, and it's arranged array of the x coordinate, array of the y coordinates, the high bytes, an array of the low bytes of the x coordinates, an array of the low byte of the y coordinates, and then the same for the velocities. I have 2-byte velocities because I'm using fixed point. And I'm cheating here if I'm going to be faithful to the original game, because I didn't know about fixed point when I wrote Lettoroids. This was a huge problem. I didn't know how to get movement that was not in the 8 directions. It's like increment y, a pixel per frame, or increment x, a pixel per frame, or increment both, and then you would get the diagonal. But how would you get any direction? And I really, I didn't have ChatGPT to ask, didn't have the internet. I had to figure it out. And so what I did on that original game was I had 16 directions, and I faked the extra 8 directions by having move 1 in one axis every frame and move every other frame in the other axis. And so in this way I was able to fashion 16 directions. But I didn't know about fixed point. And I only figured fixed point out by the time I transitioned to the BBC Micro, and I used that in the game Astro Tracker, which was a kind of asteroids sort of clone. But I'm using fixed point now because, I know fixed. So in order to do fixed point, I have high bytes and low bytes. And the point is they're all separated, because they might as well be, because the code has to treat them separately, because I've only got an 8-bit CPU. By doing it this way, it means that I can then have routines that access any sprite with an index that goes 0, 1, 2, 3, 4, 5, 6, so on. If I put it together so that they were all the way that we think about it, we don't even think twice. You make a structure and you put in, here's the x coordinate, the y coordinate, the y velocity, the x velocity. Then I might have to have 16, well, how many is here? It's 8 bytes. So I'd have an 8-byte structure. That means that my X index register, which is an 8-bit index register, would have to be 0 and then 8 and then 16. But because I don't have a multiply, I would end up needing to shift bits around. And then not only that, I'd run out of memory. Because I would have danger of running out of memory, because I can only have a number in my index register that goes between 0 to 255. And so if I go beyond that, then I have to start adding much more code, and it's going to slow things down tremendously. So I'm using this technique instead. It just means that I can have X, the index register 0, 1, 2, 3, and it's striping. You can think of it like striping. Because the instruction, the opcodes exist to access memory with an index from the X register. So I get this for free. It's just a different label in here. And so that's what I'm doing. So if I want to get a third sprite, I need to start putting the data in on there. Hey! Mike, haven't seen you in a very long time. Welcome. I was thinking about you today, actually, because you gave me that lovely poster. I'm trying to get it framed, but I haven't gone. The Watership Down poster. So when I've got it framed, I'll put it up on the wall. Mike sent me a Watership Down poster all the way from Australia. There was a problem with it, that it got delivered to the wrong address, because the forwarding, the company that forwarded it, they had my wrong address, and it went to the wrong address, and we eventually managed to get it back, and it was fine. But whoever was there at that address had cheekily opened the package. We suspect they'd gone and put it up on the wall themselves. So it's had a bit of a journey, but I did safely get it, and I'm just trying to. No, I did get it. I thought I told you I'd received it, but yeah, it will end up on the wall as soon as I figured out how to get it framed around here. So anyway, you get diagonals move one. How fast must it be? It's not, that's the point. To make it smooth, you just need to make sure it doesn't stay still for 2 frames. So if you think about it, for completely smooth movement, your minimum speed is 1 pixel per frame. That's your minimum speed. So if you want to do a diagonal, move 1 pixel per frame in the X and the Y, and then you'll have perfectly smooth diagonal movement. The problem is that is going to be a movement that is faster than 1 pixel horizontally or 1 pixel vertically, because of geometry, Pythagoras. You end up 1, 1. This is going to be the square root of 2. So as a result, if you do the right thing and say we're going to use floating point, and we'll make that diagonal, therefore not 1 diagonal pixel per frame, but we will make it 1 spatial unit per frame, or 1 pixel distance along the diagonal, you are now moving it less than 1 pixel per frame, and you will get less smooth movement. Which, something to bear in mind. I think with this game, when I recreate it, I'm going to go and be faithful to that, rather than do the other thing in order to get this smooth movement. So, anyway, so to continue, I have my striped structure here. We can see that the first sprite starts at 100, 100. The second one starts at 32, 8. And I'm going to just put in a fourth one that I'm going to start at 64, 16. And its velocity is going to be 0. So this is it should just work. If it doesn't, I'm going to have another mega debugging session. So I've just changed the number of sprites to 3. And let's see if this works. Yes, that worked first time. So yes, which is one of those weird things that I found, which is you would think that I would be forever making mistakes and having bugs and things not working all the time. Like things not working first time. It's amazing how often that I've been doing this, I have done stuff that's worked first time. And now I'm trying in my mind to figure out, why does that not follow through with more modern software engineering? I don't know. It's a puzzle. So, okay, third, I'm going to make that one move. But, before I do, maybe I could demonstrate the XOR plotting. Let's see. So if I just shift the position, of that sprite. So the first one was at 100, 100. So maybe if I put this at 102, 102, it's going to overlap. Right, it overlaps the one that's moving downwards. You see that? You get that little flicker because that's cancelling each other out. Now that sprite that's staying still is actually being redrawn every frame right now. But if I wanted to have that A not moved every frame, the thing is, it would still work. And I'm going to use that to my advantage, because the game originally had 10 letters all around the screen. And there were letters from A to J. And what I did, because I couldn't move that number of sprites, was I time sliced it. So when there were 10 letters on the screen, it would move one letter per frame. And so this way, I could have 10 letters moving, but they would move slowly. Obviously, they wouldn't move with wonderful smoothness. That's okay. They would be moving half a pixel per frame, but you can't have everything. And as you consumed the letters, because that's what you would do, is you'd pick the letters up, so you would have to pick them up in order. That was the game design. Then you would have fewer letters and they would draw faster. And that created quite an interesting gameplay dynamic that came out of a gameplay dynamic that just came out of the constraints of the hardware, you know. And that symbiosis, if you will, between a game design and the hardware is something that I think we also miss out on these days as well. But anyway, I'm going to make that guy move now. So to do that, I need to give a velocity. Now let's have something moving in the negative direction. This is the x velocity of the third sprite, and this is the y velocity of the third sprite. And maybe I will try a half. Now, to move half a pixel per frame in the other direction in here, I need to take the vertical low, or vertical low byte, which is this VL here. So I'm using fixed points. So the high byte is the number of pixels per frame for velocity. The low byte is a number of 256ths of a pixel per frame. So if I put 128 in there, that will be half a pixel per frame. And I'm going to try putting that in a negative. Oh, minus 128. Of course, that should be fine. No, it won't be. Because I need it to be a negative number across 2 bytes. So this is a little awkward. But I think if we do 128, yeah, that should work. You can have minus 128 in 2's complement number system. That's basically the first bit set and then 7 bits cleared. So that's fine. What I just need to remember to do is on the high byte is I have to put 255, or if you will, FF, or -1, because all of the bits, the high bits, need to be 1. So, okay, and I put that in the wrong one. Actually, that should be the third. So providing I didn't make any silly mistakes with that, I should now have 3 moving sprites on the screen. We're almost right. That's pretty good. It's just there is a problem. I can't count this as bug-free. It isn't working first time. When you look at it, you can see that and I haven't tested the fixed point stuff yet. So this is the first test of the fixed point stuff. You can see that A that is moving from right to left is actually dropping down a pixel every now and then, but I was expecting it to be a lot more frequent than that. And I know what that is. So I've got my labels wrong. So the VH is the vertical velocity, but it's the x velocity high. VL is the x velocity low. So was it my imagination that it jump down. Maybe it was. I could have sworn I saw it pop down. No, I hallucinated that. That's freaky. Okay, it's actually not moving down at all, and that matches what I would see here because I didn't do anything to the y velocity. So the third byte, I'm putting -1 on the high byte of the x velocity. The y velocity is labelled W just because I run out of letters. So I'm going to put -1 for the high y, and this one here is the low y, which needs to be -128. Let's try this again. Yeah, that looks correct, except it's going up the screen instead of down, and that's of course because the y is 0 at the top and increases as you go down, and this is because memory gets further, higher memory the further you go down, because generally the hardware that draws these images start at some memory location and then increment the memory that's being read as the beam goes from top to bottom. So that's, if you've ever wondered why you sometimes see that the screen, vertical screen, starts from the top and goes downwards. That's the reason why. It's the scanning from the beam. Thank you, Zhuanja, for coming. I will. Yeah, by all means, I still use Skype. You can send me a message anytime. All right, take care. So there's my third sprite, and so that's all looking good. And we're going to see now how many sprites I can get to before I get the noise. So this is now we're reaching the point of the performance test. So this is exciting. Let's see if I can go a bit further. We're going to go to 4 sprites. Let's put one at, say, 77x, and I just got a message from I'll take a look at that after the stream. So 7744 is going to be the 4th sprite's position, and then we give it some kind of other random velocity. Maybe go faster this time. So we're going to go 2 on the x, no, 2 on the x velocity, and 2, let's go 1 on the y velocity, which is wh. Let's try that. Let's see what we get. I forgot to add 4 sprites. We're up 4 sprites. This is fantastic. I would have been over the moon if I had 4 sprites back in 1980. I didn't use this technique back then. Look at that, 4 sprites. We're going to go, I think I can get to 6, I think, before we start seeing noise on the screen. So that's so satisfying. 4. Let's try and get to 5. Can't wait. Let's have a look. Let's give some other random positions. I don't have a random number generator yet. So x, y, and velocity. Let's try width and height. Width and height. Y velocity 2 and VH, yeah, -1. Let's try this. Did I set that to 5? I can't remember. Did I? 5? We're at 5. Okay, we'll see if I get five sprites. Do we have 5 sprites? See, the amazing thing is that if you can get to 6 sprites, that will seem like magic, because when you reach 6 sprites, you are... Oh, that's the wind and rain. When you get to 6 sprites, you've exceeded 5. When you exceed 5, your brain goes into many mode, because the maximum number of things that people can, quantity that people can get at a glance is 5. So you go to 6. Look at that though. No, there's no snow. The snow will start creeping in at the top of the screen when we start getting that. All right, 6. Here's the big one. I mean, this is going to be just not just a Letteroid, so I'll have to call it Letteroids 2. And maybe I'll release it for those enthusiasts who have ACORN atoms. Wouldn't that be exciting? That feels like something worth doing. Right. How about we go, 99 and, I don't know, 11 in here. And we'll need to pick some other new random velocity. I'm going to go to 3 and 2. So it'll be a really fast one. So this is sprite number 6. Can we do it? Can I blit 6 sprites in the V blank? Oh, yes! I need to check, are there really 6 there? Can I I need to sort of freeze it. Is there a way of freezing it? Oh, yeah, I can just bring up the menu. So, no. There we are. The evidence. We have 6 sprites. I would have thought that was impossible. I'll go back into a time machine, back to myself in 1980, and say, why don't you try this? I would have achieved something in my life. All right. I'm thrilled. I've got 6 sprites. I've got to try and push it. Can I get to 7? You have to remember that these sprites are being rotated. They're all of them being rotated backwards and forwards. But those rotations, which is the slowest part of drawing the sprite, they're all being done outside of the vertical blank period. They're being done before we hit the vertical blank period, and that's the trick here. And I think probably when I did this back in 1980, I was rotating and plotting the sprites in the actual V blank period, which is why I couldn't plot that many. All right, I've got to try 7 at some point. That, you know, let me check. Yeah, the speed's 100%. Phew. It's like if it'd been running at 500%, I would have been cheating. I wonder what happens if I run it at 50%. Oh, I think it doesn't. Yeah, it doesn't change the way. Is the snow off or on? Let me check that too. No, I know the snow's. Yes, I know the snow is. You can set the emulator to hide the snow, but if I turn off VSync, we will see the snow. So I'm just going to do that just to make sure that this isn't fake. No, see? That's moving pretty fast still. That's how fast it could move if we didn't have to be locked to VSync. But, you know, what you're seeing there in that rippling pattern is the conflict of the CPU accessing VRAM at the same time as the video circuitry is. So I mean, you know, modern hardware doesn't have that limitation. In fact, even the BBC Micro didn't have that limitation. Okay, so let's go back to this. So we've got our 6 sprites. Of course, a real test would be to get this onto the actual ACORN Atom hardware. That's going to be fun. I'll do that later stream. So let's try 7. Can we do? I really suspect at this point at 7 we'll start to see some snow. 100 and 10 and 120 random position, and for velocity -1 0, because I haven't got any horizontals, so this will be a horizontal movement. And 7. I was right. I was spot on. The reason I figured that it would be 6 is because I did a rough test to see how many sprites prior, and the feeling I had was it was about 6 that we'd be able to do. Can almost do 7. It's possible that by optimizing further I could possibly get a 7th in, but this is way more than I need. Though what this does mean is that for Letteroids 2, and this would be Letteroids 2, I could have more than one enemy at a time, because the original game would have... Oh, you know, I think I time sliced the enemy letters, which were Greek letters. I think I time sliced those as well. So if I did, yes, I did. So in fact, all the enemy letters and the pickup letters you had to pick up, they all count as one sprite, because they're all being, only one of them would move per frame. And because I was using the XOR, it means that, you know, you can leave it on the screen and not draw it, and it just stays there. It's the other advantage, rather than sort of clearing everything, or you're using a double buffer or whatever else, right? You just... so maybe I could only draw 2. If that was the case, I could only draw 2. That's the ship and the letter, the time slice letter. Then this is 3 times faster than what I did in 1980. So there we are. All right, I'm going to change this back to 6 so we don't see the snow. And what would be nice now is just to make sure that I can have something other than the letter A, and that's never been tested before. So we could try that. Now my sprite data is held in a very annoying format, but it's efficient. Every sprite is also indexed 0, 1, 2, 3, which means, and so on, which means that the 8 bytes of every sprite, because each sprite is 8 bytes, which gives us 64 pixels, they're also striped. So this is the first byte, because you might say, why isn't it not that byte? It's because the way that it works is little endian. So in memory, it starts with the least significant bytes and then the most significant bytes, which means this is actually the first byte in memory, is this one, 18 here in hex. So the first sprite is 18 on the first line, 24 on the second line. This is starting to sound like the I Ching. 42 on the third line, and so on. So if I want to do the second sprite, which I haven't put the data in there, I need to start from here. I want a letter B. And I'm just going to do it directly. I mean, I might as well. I mean, why not? I could draw it out, but I might as well just picture it in my mind. So we've got, depends how I want to do the B, I suppose. But let's start off with FC. That's 1111100. Then the next one, I'm just drawing. I'm doing 8, and then 2. We'll see how oh, no, not there, not there, down here. 8 2. And then on the next byte we want 8 1. And then on the next byte 8 1 again. Now we're on the 4th. No, 8 2. I need to come back a bit. And then on the next one would be F, because the line is the same as FC. It comes back to FC. And then from FC we go back to 8 2. Then 8 1. And 8 2. Well, that's a problem because I need it to be the same at the bottom and as at the top. So we'll do FC. So this is programmer art. the original programmer art. FC. Then this goes to 8 2. And then 8 1. We'll try it and we'll see what happens. That's my first attempt at drawing a B in hex, in lines. Right. And now, before I start getting fancy, I have different letters for each of those. I'm just going to try and switch these all to B. And in theory, I need to find where that was now. So it's in Move Sprites. We go to Move Sprite and Sprite Address. So we get the address and then shift the sprite of the. So Y is the image. Somewhere in here I say, oh, it's here. It's hardwired here. This is the sprite image index. I have 2 of these for the 2 buffers. So in theory, if I change these both to 1, I should, we'll see, I should get Bs. And now we see how close I got with my visualization of hex bits. That's not bad, is it? Let's be honest. I think it's going to be a bit, it's not quite right, but it's pretty close. I'm going to make that second, one of these letters not move so that it makes it easier to say the last one. Oh, I think I have a mistake in 1 2 3 4 5 6 7. Oh, right. 1 2 3 4 5 6. I wonder if I can, it might make sense for me to just put these, I don't know, whatever. 1 2 3 4 5 6. 1 2 3 4 5 6. So one of those sprites is now going to be stationary. It's up there, so we can look at the bit pattern. And yeah, I kind of remember the B being prettier than that. So there is a mistake on the bar, and of course it's in the middle, and there's a thing that it's 8 pixels high, so there's going to be a bit of asymmetry of 1 pixel. I'll try something. If I go for the FC to FE, no, that's not so good. Maybe, all right. I think on that top one, I don't think I've got the space to try and sort of make a sort of curve on there. So maybe I'll just go F, E, and then this goes immediately to 8.1. I'm just going to see what that did at the top. Yeah, I think this makes sense because, I mean, this is fairly low resolution font. So if I did that and then do 8.1 again and then 8.1 again instead of 8.2 and then FE and then 8.1 again, we'll try that and see what we get. FE at the bottom. That's a bit better. I just don't like that bit, literally a bit above FE. It should be 8.1, not 8.2. I think I prefer that for my B. So anyway, that will be fine. And shall we also make a C while we're at it? C is easier. So that's going to be FF. Well, maybe I'll do 7F. And then 80. And it's just 80 all the way down, you know. And we get to here, we can do F7F again. And to see that one, I'll need to change the hard wiring that I put in so that we're on the second. So it's looking good. I just need to add some kind of system for there we go. I can refine that later. In my memory, they look more beautiful than this, so that's we'll say that is nostalgia. Right. Now I can't help it. I'm going to just tweak that a little. I'm going to shorten the length of the top and the bottom of that C. E. I think that's a bit better. Yeah. Right. So the next thing is to figure out how to, or where to put the information on each, what the character of each sprite is. Well, I guess that's just, oh, that's easy. I just need to make another one of these sprite, and sort of like I call it image. Sprites image, and this will be a number. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. And we can do 0, 1, and 2. This is straightforward, really easy, because I've chosen this method of storing the data. Your data structure is the most important part of software design, figuring out how you lay out your data. It's nothing to do with objects, it's to do with data. Rant beginning. All right. Where was that bit that I had? It was the one of where I did the hardwired thing, somewhere in here, hardwired. See, instead of doing that, what I need to do is load into the accumulator the X, you see, is the index of the actual logical sprite. So all I need to do is take that sprite's image thing, comma X, and so now I have in the accumulator the index of the sprite I want to draw, and then I do a TYA. I'm transferring, no, TAY, transfer. So that's it, and I just need to do that again. So really just going from that hardwired thing, I've just added, you know, one opcode extra, and I think that should give me different sprites with different images. Actually, yeah, 0, 1, 2, 0, 1, 2 again. I've got 2 because I have 6 sprites, and I shouldn't have any performance hit, and it worked first time. See, it's like the thing that really helps is how quick a change gets visualized. I make the change, boom, check the change, it's there. Make the change, it's there. This is fun. You compare that with what you get generally these days. It's very working in Unity. You hit play, and it's like this was like this on Kickoff Revival. Hit play. 1, 2, 3, 4, 5. Starts up. It's like you do that all day. No, I like this instantaneous stuff. It's fun. Let's move. Have them all moving. Look at that. So let's get some more letters in, and then let's just. Oh, I've had a change of a thought on the letter B. I'm going to do a little tweak on the letter B. Just that. Oh, yeah, that's better. I've seen that, and that was interesting. It's still a lottery, but I might just get a ticket. Epic Store just went open to indies. Just don't forget, it's all a Ponzi scheme. It's just a Ponzi scheme. Everybody gets excited about indie game development. They want to make their indie game, and for everybody who makes an indie game that anyone ever gets to hear about, there were like 10 indie games that nobody ever heard about. But they're all feeding off each other in terms of You know, if you make a game to release on some platform like that, what you're actually doing is working for the platform. You have to, and you have to be okay with that. You're working for the platform but getting paid nothing, in the hope that you will be one of the lucky ones. It's a lottery. But the fact that the reason why I'm not quite so harsh on it as I might be with Unity is because the quality of the engine is, as far as I'm concerned, far superior. It's built for production, whereas Unity seems to be built for getting people hooked. You know, so yeah, there's the better rev share as well. But it's like Unity is based on the principle of getting people hooked because it's easy to start the game, but then you end up with, you know, the Pleasure Island syndrome. It's like everybody, yeah, we're going to make a game, yeah, we're making a... But you find that finishing the game is the difficult bit. So I'm been using Unreal in my day job for the last 2 years, and I'm actually very impressed overall by it. So that's one thing. Then there's the fact that if you publish on that store, they waive the royalty, because their model is different. You don't pay for anything, but if your game is successful, then you pay a royalty. I know, that's fair enough. I mean, they're a business and they have to. Frankly, it's healthier. It's healthier than the Unity one, where they have thousands and thousands and thousands of hopefuls that pay for the privilege of taking part in the lottery. With Unreal, you're not risking much of anything. So I think that's healthier. They waive that fee if you are going on the store, as I understand it, and then the revenue is much less, and that's also appropriate. That's a revenue that they take because it's a lottery. So I think it's potentially exciting. Well, we'll see. We'll see. It's kind of, would be nice to have a platform to release experiments on. I like that B a lot better. So we've done C. Let's do D. Yeah, D. A little troubled by that C. A little troubled by that C. Doo-dah. I'm going to just refine the C a little bit. Oh yeah. Just see if that's a better C. That's a much better C. Yeah, that's classy. We'll do D now. So this would be F. Let's start with F8, and then we'll go to 8, 4, then 8, 2, then 8, 1, then 8, 1, then 8, 2, then 8, 4, and then F8. It should give me a letter D. Oh, yeah, except I haven't set my, so this would be to 3. So we should have A, B, C, D. There is a D. it's a little pointy, isn't it? I am, yeah, not a fan of that D. We'll do a little tweak on the D. We'll start with FC 8, 2, 8, 1, 8, 1, 8, 1. Oh, easier if I do it from the bottom up then. Right, so from here we do FE 8, 2, 8, 1. Let's see if this is a better D. Oh, but I made a mistake. I need to stop that moving. Right, where are you, D? There. Oh, it's just the last one I got wrong. 8. Oh no. Oh. FC. I think I made a... something's not right. Oh! Oh, it's perfectly fine. That's a good shape, D. It's just when it's moving diagonally like that on this screen, it kind of looks like it's asymmetrical. That's to do with the movement. It started jittering, but that's not actually me. That is the emulator is fault. See, it's losing VSync or whatever. It's smooth again now. Right. I need to get to 6 letters and then I'm happy for now because I have 6 sprites. So we'll go to E, and that is going to be FF 80 80 80. Maybe F0 80 80 FF. That should give me the letter E. That's a little ugly on the length of those arms of that E, so that's going to be a quick fix. We'll just shorten top and bottom. There we go. And then when I've got F, that's very similar, really. We're going to just use the same pattern and just change the bottom. So it's FE 80 80 80 F0 80 80 80. And so we should have F now. So I've got my 6 sprites and each one has its own letter. There we go. Okay. So I'm going really well now. What I need to do to implement the game design, however, I don't need to use all this sprite power. I can save the sprite power for things I couldn't do originally, like explosions and God knows what. It's such an opportunity to make use of this extra power. But the thing is that the way that I move those letters with the time slicing became part of the design. So what I want to do is be able to say, you know, when to schedule the movement of these. I want a way of being able to say these letters should be time sliced. So I'm thinking, what's a good way of doing that? In the routine where it goes through drawing the sprites, I have a place where it does that. So that's happening in move sprites, draw sprites here. So X is the index of the sprite that I'm updating, and I just have a nice simple loop here which starts with the last one, decrements X, and branch if plus. It's a little bit easier to do it descending in that way. But this means that X has the index of the specific sprite instance. I suppose I could make a counter for the frame, the current frame. Maybe would be up to 256, so 1 byte count of the frame, and then use that against the index of the sprite. You see, do a modulo. See, the way I would do it before is it would just be the routine to move the sprite, and I just would call them individually. But now I have an engine. I have a little sprite engine here. So the sprite engine just wants to go through and draw the sprites. So I need to have a different way of doing it. It's always going to draw the sprites unless I tell it not to. So what's a good way? Because what I want to do is, I can't do a modulo because the modulo is expensive. It would be a division. I don't have that. This 6502 modulo, division. What are those things? Classic way of, oh, all right. What I could do is have, I'm going to try something. I don't know if it's optimal, but it seems like a pretty good idea. I can add a further thing to each of these sprites which manages how often they are drawn. So I call this one sprites slicing. And the number that we put in here for each of these sprites determines how often it is drawn. That's useful, right? I could say, well, I could use a bit mask. Oh, bit mask. I might have two different kinds. I think it's easier if because I might want to have slicing in the sense of saying only update this sprite on every other frame, but update this other sprite every other frame. And so in this way I have two sprites which are moving at half the update rate, but then I can move both of them, you know, in the same, you know, it's cheating. You make two sprites out of one, in effect, in terms of time, drawing time. But according to the game design, you know, I need to be able to have 10 letters, and it cycles between the 10 until there are 9 letters, when it cycles between the 9, and when there are 8, it cycles between the 8. So for this reason, if I want to do the other kind, I'll just have another value I'll call it something else. So slicing is just going to be no, this is non-trivial. Unless I have a counter that resets. So if I know I only have 5 letters, I will have a number that goes 0, 1, 2, 3, 4, 0, 1, 2, 3, 4, 0, 1, 2, 3, 4, so on. The problem is that it's not like, oh, but the letters actually go in order. That's part of the game design as well. So you start off with A. It's the first letter. So after A is gone, then you've just got B, C, D, E, F. So B, C, D, S. If the I can use the index. Right. I'm trying to balance in my mind how engine-y this is versus the actual design need here. All right. I think I'm coming to a decision. Oh no. I mean, I could just say, do I want it sliced or not? And if I say it is not, I think I'm going to call this sprites flags. Good old flags. It's always good. You always have flags. You can't go wrong with a flag. And there's going to be a bit in there, and that bit is going to say whether or not the sprite should be time sliced. And there's a specific kind of time slicing that's involved. It's like every frame we only draw what if the time slice bit is set, then that sprite, only one of those sprites is drawn per frame, and we remember which one it was that was drawn last time. And just trying to make sure that the logic is fairly simple when I come to implement it, but we'll try. So what I'm going to do is make it so the first bit of the sprite flags would mean that it is time sliced. I think I'm going to have to dive in onto that. I want to make these 6 sprites time sliced. For example. So if I do that, then the routine is when you find, I start drawing as soon as I come across one with the time slice bit set. Oh, I could try something else, which is use a second bit, so that the first bit is the one that says, yes, I wish to time slice it. The second bit is, it's been drawn. So then when I go through the list of sprites, it skips if it has been drawn until it finds one that is time sliced but hasn't been drawn. Then it draws it, it sets the bit. So that's fine, but then I need to know how to clear it. So when it comes back to the beginning again, I need to clear them because now those bits have all been set. And I don't really want to go through and clear them all. That's just such a waste. So then the sense gets reversed. So I need to start clearing them, and then I need to remember whether I'm clearing or I'm setting. It's a bit of a mess. Oh, maybe not. Okay. I'm going to try. Yeah. Okay. I'm going to have a single byte value here, which is going to be the say slicing bit, and I just want 1 byte, which is going to be a 0 in here. And what I'm going to do is have the slicing bit, which I exclusive OR at the end of each cycle, when it has finished going through all of the sliced sprites, it's going to reverse that bit by doing an exclusive OR on it. Then, when figuring out whether or not to actually draw the sprite, it will exclusive OR the state of that bit in there, and this has the effect of flipping the sense of whether it should be cleared or whether it should be set. This seems quite nice, because that should be quite easy to implement. I'm going to give this a go. It feels a little bit scary, but we have our two draw. Well, you see, because the other part is that I need it to bypass different parts of the drawing process. So where do we do that? It's in draw sprites. I'll need to repeat it in draw sprites too, but also in move sprites. I don't want to have to move it if, you know, it isn't being drawn. So let me try. I'll just try. Since this is the first one, I'll just try it in here. So the idea is I need to look at the sprites flags for the move sprite. For move sprites, where did I put them? I can do load a sprites flag, comma X flags. Sprites. Let's get that right. Sprites, flags. There it is. What I want to do is AND 1, immediate 1. So that's ANDing the first bit. At this point, if the result is not equal, then it means we're time slicing. Right? But if it is equal, then we just continue. So what I will actually do is say branch if equal to, I need to put a label in here, like so. And this label I put here. So what's going to happen is that if that bit is cleared, it's just going to draw as normal. Otherwise, I'm basically constructing an if statement, right? So it's basically now, if it's not equal, because after this ANDing on bit 1, the first bit 0, of sprites flags, if this is not equal, then it means that bit was set. If that bit is set, then it means I need to time slice this. So according to the plan that I have, we check bit 2. Now it means I need to load this again. Now, that's annoying. It would be nice if I could just do a bit test, but you know, that's a 68,000 instruction. I don't think the 6502 had that. So I don't think I have any choice. I just have to load it again and then AND it with 2. I can look at optimizing it possibly later. So Now, if that, but I need to also exclusive OR it with my slicing bit. So we exclusive OR it exclusive OR it with the slicing bit. Take care, Corporal. So EOR is slicing bit and 2, immediate 2. And so what I'm doing is I'm checking to see if that bit is set. Now, normally the slicing bit, well, at the beginning, the slicing bit is cleared. If the slicing bit is cleared, you exclusive OR with 0. That doesn't actually change anything. So 1 exclusive ORed with 0 is still 1. And 0 exclusive ORed with 0 is still 0. However, if you exclusive OR with 1, it reverses. So it becomes 1 exclusive ORed with 1 becomes 0, and 0 exclusive ORed with 1 becomes 1. You following me? So I can use that bit, the slicing bit, to change the sense of whether I'm looking for it to be cleared or set. This way I don't have to go through all the sprites and clear them, this bit. We don't have to clear this bit every frame. See? So what we do there is if the slicing bit, if bit 1 rather than bit 0, if bit 1 is set at this point, it means it's been drawn, so we skip it. So branch if not equal and I need to make a unique name for this label, so we're going to call this move sprites 3, but basically it's done. So at this point it says we're done. I could make it a little bit more meaningful, that label, but the problem is the naming. I suppose I could do that, but I need the, otherwise it's the way this, and it's true of many assemblers, this label, if I go in here and put a label, I could jump from this to this, for example. There's nothing that stops you from doing that. So basically I need to have a unique name for each of these. But this is, oh, but that is unique. I can do that. That's fine. Smooth sprites 1. All right. So basically then we have check to see, let's just do a recap and see if this is working or not. We look at the sprites flag and see, we do and 1, and immediately I've got a problem because for some reason I had this in the wrong place. So try again. If the sprites flag bit 1 is set, then is cleared, then we don't do anything unusual, we just go straight to normal drawing. Otherwise, we load the flags for this sprite, and again, we exclusive OR with the slicing bits. Now, I need to remember bit 1, because the slicing, whether or not I have drawn on this pass, is in bit 1, not bit 0, so I need to remember that. I exclusive OR the slicing bit, and I mask off the other bits, so then I can see if this result is set or cleared. Now, if the result is set, it means that we skip because it's already been drawn, right? Otherwise, it continues. You see, this is beginning to get complicated because I'm going to have to replicate this. But I suppose, we'll see. I'll go with it. I think that's all that's all that's really necessary, except that one more thing, which is that if I'm here and it means I am going to draw the sprite, I need to remember that I drew it. And so for this, I need to set the slicing bit 1. Now, I know that it's equal 0, so there's nothing for it here. I'm going to just load a immediate 2, and I think I can do an OR this with the slicing bit. I think that is a permitted opcode. So I'm basically setting a bit in slicing bit 1 in slicing bit. The wonderful thing here would be to try this out and see if it worked, but the problem is that I need to do more changes for this really to be valid. But what I could do is just go and say these slicing bits, I'm turning them off, and then none of this code should execute. I'm trying to think of how I can get to something that I can test. So this should work normally. So I've got a test moment here. I can actually try this. You don't want to go too far without testing. And that's fine. That's great. So it means that change, which is like a little light refactoring or whatever, I've added the facility in, but it's turned off, but it's not disrupting normal operation. I'm going to just review this again. So what I'm doing is loading the sprites flags for this particular sprite and checking bit 0. If bit 0 is cleared, then I just draw sprites normally. However, if it was set, I check bit 1, sorry, the second bit of the sprites flag after having EOR'd it with the global slicing bit, so that I'm able to reverse the sense of the check. And I AND that with 2, that's masking that bit, so we're only interested in that particular bit and no other. And if it's not equal 0, then it means it has been drawn, and so it skips the drawing routine, or the move sprite routine. Otherwise, I set the slicing bit. Okay, I think that looks fine. The problem is that I shouldn't be setting the slicing bit. I should be reversing the slicing bit for this algorithm to work. So I need to do EOR. Let me just check that works, so that the EOR is a valid opcode, which I thought it was, so that's fine. Right, now we're good. I need to reproduce this again here. So I'm adding quite a bit of code. So this is now move sprites 2, move sprites 2, move sprites 2, done, move sprites 2, done, like so. And just double check my naming conventions, my naming here, not convention, just the naming, to make sure that's right. Let's just check again. So at the beginning of the loop here, we get the flag, we AND it with 1. If it's equal, we just jump normally. Otherwise, we get the second bit and we exclusive OR it with the slicing bit. And if that is not equal, it means that we have actually already drawn this, and then we exclusive OR on that bit, and I think that's fine, and this should also have no effect, so we're good with that. So that's move sprites done, and then we have the draw sprites. Now what happens if I do move sprites, if I do a draw sprite without a move sprite? Yeah, that's probably not a good idea. So, but there is a, you see, the thing is that I've modified the state in the test here, which means that then the draw sprite test is no longer going to make sense. It's like I can't redo this because there's a side effect in the second part. But what I could do is use a third bit of my flags to say whether or not we should continue with operations on this particular sprite, because we always do a move and then we draw. Basically, this bit is going to say whether the draw buffer is valid or not. I think this makes sense, because then that means that the draw sprite should only be done if the draw buffer is valid, and I think we'd be good there. That makes a lot of sense. So let's go back to the first one here, and what we want to do is indicate whether or not the thing is valid by setting or clearing a bit in the slicing thing here. So we load a immediate to at this point I want to set a bit in the slice, so we need to at that point swap the sense of the bit that indicates that this has already been drawn, but I must always set the one that indicates if the thing is valid or not. What's a good way? I'm trying to think of an efficient way of doing that. And I don't want to do a premature optimization on this. It's just going to make life a bit hell. So what I'm going to do is we go all the way back up here where we loaded the sprites flag. And I have in the accumulator the sprites flags here. We're going to use bit 2 to mean whether or not it's valid. I might as well, while I have it in here, do an AND with F B. So FB is all bits set except bit the third bit, which is clear. So this is clearing the third bit, and I need to start adding comments now as this is getting a bit intricate, but this is clear the valid bit, which is bit 2. Right, so this leaves all the other bits alone, but will clear bit 2. And so in order to clear bit 2, I need to then store this back into the sprites flags, right? So that looks fine. And then I carry on as I did before. I still have that sprite flags in here, and I do an AND 1, and it just continues. So the only difference that I'm doing now with this is clearing the valid bit at the start of moving the sprite. That's fairly cheap, and that looks all right to me. So I don't think I copied that quite correctly. I think I missed out a line. It's 3 lines. Ah, I put it in the wrong place, I think. That's the one. So load, sprite flags, I store. Yeah, okay, I think that's good. This again should do nothing right now. It looks like my camera just died. So what fun. I'm just trying out this camera, probably overheated. So just bear with me a moment while I'm trying out, as it's got a ZV-1, I'm trying it out. I'm not impressed with the streaming capability if during a stream the camera just dies. It's not nice. So I'm going back to my other webcam. Picture quality is nice. So just bear with me a moment while I see if I can get that back. Video capture device. Yes, it. And we're now like that, and I'm probably apologize for the huge face now, as I'm probably there, but I'll just carry on like this for now because I don't want to stop what I'm doing. Are we there? Are we good? Is that good enough? Good enough for streaming. Right, so where was I? I think that is... Hello? Oh, there's an error. What do we have? On line 297, too far. This is always very annoying. What we basically have happening now is that this branch back is probably, the code lies over a boundary, a 256 byte boundary, and so as a result it can't reach, and it's really annoying when this happens. The only thing that I can do, I mean, I suppose you can leave this refinement for optimization at the end. This is like you can move code around to try and avoid this problem when it happens, or you can do the following, which is jump around a jump. I'm just going to jump around a jump here, but yeah, it starts. I tell you what, I'll use this naming convention here, or actually in this case I could just say branch, instead of branch if plus I can say branch if minus, and to this. And then, so therefore, if it is jump, if it is plus, it will do a jump. Let's see if that got rid of that one. I'm going to do the same here. It's not worth trying to be clever when that happens, unless you're desperate to optimize to the cycles. And so value not defined on line 281. Let's have a look at that. So we have, I need to $sign because that's a hex value. Let's see if we've got that. Next, line 306, I had the same thing here. Okay. And now we get nothing. That's a little annoying. I'm gonna have to figure out why we get nothing. So the first thing I'm going to do is comment out everything of this code, which is all to do with the slicing. Because I need to get back to a point where things work, and so that doesn't work, which suggests that there might be a problem. Yep, there it is. Move sprites 1. Oh, it was a crash. This should be jumping back to move sprites 2. Copy and paste. That's always a danger. Oh, it still doesn't work. Oh, that's really annoying. I'm looking at a blank screen. Sprite. So this was branch shift plus, but if you do branch shift minus to here, move, because I've gone back to move sprites 1, I went back to the beginning of the entire function, and then X is reset and it just will put it into an infinite loop. What I need to do is jump to the right place. Here we need to jump to the right place. I will try that. And I have a problem now, 9298. So things are not just working now. Complexity's gone up. You know what? There is a need for the dot there. Right. Okay, we're back. And now I can... Because none of that should have any effect yet. There. Okay, that's all working properly. Nothing has happened there that went wrong. But what I do have is that it cleared a valid bit, and then when I draw the sprite, I need to set the bit. So I know that I have drawn the sprite here, or I've done that here there. I need to load, before I decrement the index, I need to load the sprites flag, and I need to set, actually it'd be really easier if I do it this way. So what I'm going to do is load bit 222, right, bit 2, 012 is 4, a value of 4, and then I'm going to OR this with the sprite flags. So I set the flag that says it is valid. I'll just put a comment for that. Set the valid bit. And I need to add that in the second version of this routine as well, which is done just before the decrement X instruction. This sets the valid bit. So all being well, I now have a valid bit that gets set. And that's still working. Now, what should happen is the draw sprites routine. This is now much simpler, because all it needs to do is check the valid bit. So for that, we need to load into the accumulator the sprites flags X. We need to AND it with 4, which is because I'm checking. Oh dear. Something's tickling my nose. Stray hair, I know. Check the bit 4, and we need to well, no, we're checking. And so if the flag for bit 2, sorry, if that is equal then we don't draw the sprite. I've just spotted a bug, so I'll come back and deal with that, because I was about to make the same bug here. Actually, I need it, it's a bit like a continue. I need it to continue to the next one. And what I was doing was jumping to the end of the function. So what we do is we check that, and if it's equal, we need to branch to the dex. So let's just put this in like so. So we load X with the top sprite, and then, well, check the sprite flag. If it's equal, that's the sprite is clear, that the bit is cleared. It means that it isn't valid, so we skip the draw sprite instruction, but it will continue decrementing X and going through the other sprites. That looks all right to me. We need to copy that and paste it here. We need to be careful of the naming. We need to copy this label in as well and change its name. I think that's right. Then I need to go up here and fix the mistake I made here, which was that this move sprite's done. That one is needed. This one needs to go again, not before the dex, not after the dex. Did I put it before the dex over here? Yes, that's correct. So this is like jump here to continue the loop, in effect. So let's make this the third label. So if we are skipping, we branch to here. And I think that's fine. So we jump to here if we're skipping the slicing check. And if we determine that we are to skip drawing this sprite, then we jump to the decrement X. I need to do the similar thing over here. So just before the decrement X, and we need to number that 2, and instead of done, do branch if not equal to that. Just run through it quickly again. So we load the sprites, bits in there, we remove bit 2 or clear bit 2, and then we do the logic that I've been through a few times, but the point being that if we are skipping drawing the sprite, we jump to the decrement X function. Okay, I'm going to try this again. It shouldn't. Okay, we have a change in behavior. What seems to have happened there is something's gone out of whack, so that the clearing thinking. This happened when I introduced the check. I think this is to do with the check on whether or not the draw buffer is valid. and it thought it wasn't valid, and so it didn't draw. Then the problem is with the thing is with this exclusive OR plotting, is that if you don't draw the initial one, then when it's trying to clear, it actually sets, and then you end up with, you know, not stuff on the screen. So yeah, that was correct. So basically what's happened is that the bit wasn't set to say that the buffer was valid for some reason. And the reason why is that? Now when I do the move sprites, it should have set that here. I clear it and then I set it. I set it when the sprite is drawn. So I clear it here and I set it after we draw the sprite. But the problem is that it didn't actually... It could be something else. Let's check. There, I load sprite flags. I'm going to skip drawing the sprite if this is equal. This would suggest the first time it was called, it didn't think it was valid and therefore it skipped it. And we can see in here that it should have been made valid in the move sprites function because I drew the sprites. What am I not seeing? Then load a immediate for or a sprites flags and or a sprite flags. Oh, is this draw sprites all? Is a complication. Because, and this is where I need to take a break. So I'm probably going to wind up the stream here. Because what I've seen is in the plan that I had, I forgot something. And that's that I have the clear, the buffer that is going to be clearing and the buffer that is going to be drawing. So the added complication is I can't just slice without being sensitive to the fact that if it had been moved prior, in the prior frame, then I need to draw it to clear it. And so I think what basically is happening is that noise that was left on the screen, it was because of that conflict between having a single thing that states whether or not the thing was being moved against the double buffer idea, the two drawing buffers. And at this point I need to come back to it because it's late. So don't worry, I'll be continuing with the development of this game. My intention is to recreate the game that I made originally completely and to run it on the original hardware and maybe release it to the ACORN Atom community as a sequel to the game that was never actually released in the form that it was intended to be. And I'll tell you the story about that as well. It was actually published under some name that I've forgotten now. Extremely rare. It has been located and exists on archives for the ACORN atom, believe it or not. So, but instead of letters, abstract shapes were used. Publishers, eh? I'll tell you about that maybe at a future time. Anyway, thanks for watching. That's it for now. Plenty more happening. Oh, I just should let you know that I was experimenting with the setup here and doing a maths video. I want to cover, or I covered the normalized tunable sigmoid function with you know, some fancy being able to draw on the screen and stuff like that. It turned into a 2-hour video, so I'm going to cut that up and start publishing that as well. So there's a lot that I'm planning to do, and now that I'm settled in the new place and raring to go with a bunch of things, so it should be exciting. But anyway, take care everybody. I'll bid you a good whichever time of day it is, wherever you are, and see you all. Cheers.